Hello everyone. In the video today we're going to take a look at some integration using parts. Okay, so the equation for using parts normally given in a formula book and is written as follows. If we integrate some product, so u times dv dx, let's make that v a bit clearer, is the same as uv minus integrate v du dx with respect to x. So let's play around with some examples. Let's try I1. Let's integrate x e to the x dx. Okay, so firstly, why do we use parts? Well, because we have a product in here, we see a product, then we should be thinking parts, because parts is just it's just a rearrangement of the product rule for differentiation. So it's obviously going to be helpful when we see products. What about the parts formula? What's actually happening? Well, we start with the problem of integrating something and we rewrite it, and then we have a new integration problem which we hope is easier. So what patterns do we see? Well, wherever we label as our u, in the new problem, which we want to be easier, we're going to see a du dx. Okay, so we want to find, we want to label the u in such a way that if we differentiate it, it becomes a lot simpler. And we also need to keep in mind that we have a dv dx, and we need the v from that, so we need to be able to integrate this, and we want to control it, don't want to make the problem more difficult. Okay, so looking at our question, to be honest, if we see an x, it's always a good call to try u there. If you differentiate it, it goes to 1. So let's try that. So let's label it the following way. So our u is going to be x, and dv dx equals to e to the x. We should label these as clear as possible, so we pick all the marks up, and more importantly, we don't make mistakes. If we have u, then we should calculate du dx, so that's just 1. And we have dv dx, so we need to integrate to get v, integrate e, it's just e. Okay, so pop it into the formula. So we have u times v. I tend to follow a pattern. I know my eye should be looking in this direction. It should be x e to the x. And again, I tend to just have a good idea where to look more than memorizing the formula. So u times v, and then integrate 1 times ex dx. So as long as you label them this way, then you can follow these rough arrows. Okay, so if we just tidy that up, we have x e to the x, take away integrate e, and yes, our integral has become easier. We're now left with the problem of integrating e to the x instead of x e to the x, which is much easier. And if we integrate ex, it's just ex. And because this is the final step, we're going to add our constant of integration, so plus c. So there you go, the final answer, x e to the x, take away x, plus c. Okay, let's develop this a little bit further. What if we change the x to something else? What if we have maybe an x squared there? Let's try that. So let's go to a clean page. This is slightly harder. Let's call it I2. Let's integrate x squared e to the x dx. Okay, so we're going to use parts again. And if we think about this as our u, then when we differentiate it, it's going to become 2x. Okay, the 2 is no big issue. It's going to become, let's say, some multiple of x. If we put this as our dv dx, if we integrate it, we're going to get e to the x still. So if we put this into parts formula, it's going to get easier. Particularly this power is going to drop by 1. But we're not there. We're not going to get there that simple. We've still got a bit of work to do after that. So let's see what happens. So if we label these up, and if we calculate the information we need, so du dx is 2x, v is e to the x, and if we drop them in, we're going to have u times v looking this way, which is x squared e to the x. Then I'm looking here, I'm taking away the integral of 2x e to the x dx. And if I just tidy this up a little bit, I'm just going to write this. I think I'm just going to take this 2 outside the integral, like follows. So my problem up here is now reduced to this problem here. So effectively the difference is the power on the x has got a bit smaller, which should make it a bit easier to deal with. Okay, so what do we do next? Well, we could do parts again in here. See, there's a product, we see there's an x, this is going to work quite well. Actually, we've already done this one. This is like our integral I1. We already know the answer to that. We just saw it. The answer was, what was it? X e to the x minus ex plus c. Okay, for the moment, I think I'll close it there, and then I'll add my c on at the end. Okay, so I'm just going to tidy up now. So I can see there's lots of ex's. You can see 1, 2, 3. So in those terms, so I'm just going to bring them out as a factor. And what's left over? The other factor is x squared. Take away 2x plus 2. It's a minus minus here and here. And if we add c, then we get our final answer, which looks like this. So there you go. I2, the second integral, a little bit harder. You could either use parts twice or rely on part A. And part A was just a simple application of the parts formula where one of the factors was x. So there you go.